Welcome to the second part of the 2025 analysis enhancement videos detailing combined LAMBPLAN. I'm Kate Rummery and I'll be talking you through the future proofing of the evaluation. This is the first of two videos on the enhancements. As part of my section, there are three key sections. So we have the changes to the data analysis pipeline, we have the combining of the data sets and streamlining of data, and what does the base change mean? The first of these is the changes to the data analysis pipeline. The data analysis pipeline is how data is submitted from the breeder through to sheep genetics, and then we forward it on to AGBU to do the analysis. So more of the data processing in combined LAMBPLAN is going to occur at the sheep genetics end rather than at AGBU. This is done for a couple of reasons. Number one, it gives us the ability to provide breeders with better feedback on submissions. So when you submit data, we'll be able to provide you with better feedback. But also, really importantly, it reduces the computational time of the analysis. This is only a slight increase, but any increase is a good increase. So it speeds up the analysis ever so slightly. And this essentially ensures the resilience and longevity of our evaluations over time. So the size of our evaluations are growing and the number of genotypes that are being submitted each year is also growing. And this becomes computationally quite challenging and quite complex. So we need to, limit this wherever possible. So part of the processing occurring at sheep genetics will do that for us. For this enhancement video section, at the end of each section, we're going to go through what impact this has on breeding values. So there's two key bits that we look at. So does this change impact the ranking between animals? And does this impact the actual value of the ASBV? In this case, it does neither. It's just a data analysis pipeline update, so the level of the impact in this case is very minimal. Our second section here is combining the data sets and streamlining the data. So combined LAMBPLAN is the bringing together of the two current LAMBPLAN evaluations, so the maternal and terminal evaluations. This essentially will see an increase in the number of animals, sires, breeds, and genotypes in the evaluation, which makes it just a bigger evaluation that's harder to run, but also gives us some really key benefits to industry that Peter will have detailed in the first video. So there are 35% of flocks that have animals represented in both analyses, which suggested to us that we would have good linkage between these evaluations. So the linkage is coming from a couple of different places. The first is our resource flock. So the resource flock has been running for a number of years now, and it gives us head-to-head comparisons between terminal animals and maternal animals where their progeny run in the exact same environment, and they're collected for a really wide variety of traits, including carcass traits and hard-to-measure traits, that gives us good linkage across them. The other place we're getting really good linkage is from breeder flocks. So we have some sires or some flocks that are sourcing sires from two different evaluations and then running their progeny in the same environment. So we're getting good linkage from those kinds of flocks. But we've also got multi-flock sites. So this is a site that is running two separate flocks, one maternal and one terminal, and the progeny are brought up under the same environment and in the same management groups, and it gives us really good head-to-head comparisons between these animals and provides linkage for the evaluation. So in combining these two data sets, we're going to have an increased size of the reference. So our reference is going to go from just terminal to maternal and just maternal to terminal and maternal all joined together. And when we have an increase in the size of the reference, we generally see an increase in selection accuracy. So our accuracy of breeding values will increase and provide us with better information to make selection decisions. When we look at the second part of this, so this is the streamlining of data. Sheep Genetics and AGBU made the decision to remove some low relevance data. So there are 5 things we're going to remove, and I'll go through each of them. The first is the phenotypes prior to 2000. So that data is now at least 25 years old. And when we had a look at the impact of removing this data on our current candidates or animals born in recent years, the impact was very, very small. So essentially this allows us to trim out phenotypes prior to 2000, which increases our analysis speed and reduces the size of the data set, but has very little impact on our current candidates. And it's the same story for our second point here, which is the Sheep Improvement Limited, SIL. So SIL is the New Zealand genetic evaluation for sheep. And we had a data sharing agreement that essentially meant that we used some of their data in our evaluation because we had good linkage with them. But given the border's been closed for a number of years now, and we're only getting a one-way flow of genetics, our linkage to SIL is getting less and less, and the relevance of the SIL data in the Australian data set is becoming less and less. So we also tested the impact of removing this data to see what impact that would have on current candidates, and it was the same as above. It was very, very limited impact on our current selection candidates. It's important to note for both of those two top points that we're removing the phenotypes from here. So that doesn't mean that we're removing pedigree. So if you have pedigree from pre-2000 or coming in from SIL, your pedigree will remain in place. It's just the phenotypes that are being removed. The third point here is our syndicate sire groups. So in LAMBPLAN, we don't get a lot of syndicate sire groups submitted at all. But they're computationally quite hard to compute. So we're removing them, and instead of using a syndicate sire to inform pedigree, we'll use a genetic group in its place. Breeders are still welcome to submit syndicate sires, particularly in their repro data. We just won't be using it as a direct sire. The fourth point here is our single animal contemporary groups. So a contemporary group is a group of animals in which we can make direct head-to-head comparisons. So these animals in a contemporary group have been brought up in the same environment and have been treated the same throughout their life, so that we can make head-to-head comparisons between them. When we only have one animal in a contemporary group, we can't make any comparisons to any other animals. So essentially the data from that animal is completely ineffective. Again, same as the sire groups above, this is computationally tough to work with, and it chews up a lot of time. So we're able to remove this without impacting the data at all. And the final point here is our hogget, fat and muscle phenotypes. So with data recording patterns over time, we're getting less and less hogget, fat and muscle phenotypes submitted to the evaluation. Most of our data is coming in at a post-weaning age stage. And essentially that means that we can stop reporting breeding values and stop using phenotypes for hogget, fat and muscle. And the breeders that are impacted by that will be contacted or have been contacted. These changes to, I guess, remove low relevance data have some really positive impacts on our evaluation. So it increases the analysis speed by 25%, which is fantastic. And it means that we get more effective data used. So increasing the speed is really important as we look forward into the future with more and more animals submitted every year and more genotypes submitted every year. When we have a look at the impact of these changes, we can see the first one here, which is combining the maternal and terminal data sets, has a really large impact. So this will impact the rankings between animals, and it will also impact the value that we see when we look at the ASPV. So this is probably the largest impact of the entire analysis enhancements and the combining of the data sets. It'll have a really big impact on the way that we look at breeding values and the ranking of animals. The rest of the points here are the streamlining of the data, and none of them will have an impact on the ranking between animals. But the first two, so the removing SIL data and the pre-2000s data, will have an impact on the actual value of the ASPV. That impact will be pretty small, but it will be there. The other three will have no impact on either the ranking of animals nor the value of the ASPV, and the impact will be very small. Moving on to our third point here, which is what does the base change mean? So ASPVs are presented as an animal's superiority relative to a base. So the base historically has been the mean of the 1990 born animals, but given that we're removing the phenotypes pre-2000, we can't use a 1990 base anymore. So we're updating our base to the year 2000. So this aligns with the start of when the phenotypes come into combined LAMBPLAN. So this change will have quite a big impact on the way that the way that breeding values appear. So it'll be really important to re-benchmark where your animals and your flock sits relative to the percentile bands. We have some examples here and on the next slide. So when we say we're changing the base year in LAMBPLAN was 1990. So animals born in 2025 were compared to base, a 0, that was in 1990. We're changing that base to 2000. So in combined LAMBPLAN, animals will now be compared to a base level of 0 in 2000. And this will quite drastically change the way that our breeding values appear, not so much the ranking of animals, but the way that they appear. So this is just an example here. This animal is in the top 5 percentile in both terminal LAMBPLAN, but also in combined LAMBPLAN. So in its normal or current terminal evaluation, its ASBV is +12, and that means it's in the top 5%. In combined LAMBPLAN, its breeding value is +6, so significantly reduced, but it's still in the top 5%. So it's really important that breeders get their heads around the new numbers and what they look like, because the numbers will look significantly different, but the percentile bands will still be there to help you benchmark against industry. So if we have a look at a real example, so this is data that's actually come out of our current maternal and terminal evaluations and the combined LAMBPLAN data set. We have two traits here, post-weaning weight on the left and IMF on the right. If we have a look at our maternal and terminal post-weaning weights, the average for maternals sat at roughly 11 or 12, and for terminals it sat at about 14. If we have a look at that average now in combined LAMBPLAN, it sits a bit closer to 5. So that's a really significant difference. I guess the level of change that we'll see will differ across traits. So in some traits, we'll see a really big change, and in other traits, we won't see much of a change. So IMF is one where we will see less of a change. So in maternals, it's currently, the average sits at about -0.4, and it's roughly the same in terminals. But when we have a look in our combined LAMBPLAN data set, it sits at about -0.1. So a much smaller change relative to P weight, but still a change, and you'll still need to re-benchmark. We'll have videos explaining how to re-benchmark your flocks. So we'll have one on our next steps as a breeder, what steps you need to take to sort of re-benchmark. But we've also produced a tool that will help you to compare your current results in either the maternal or terminal evaluation to your results in combined LAMBPLAN, and we'll have a video explaining how to use this tool.